All right, everybody, welcome to Pythagorean Theorem. So Pythagorean Theorem, we're going to talk about the equation, and hopefully you've seen this before. It is the square of each side, and if you add these two sides, you should get the square of the longest side, which is also called the hypotenuse. This is your C value. So if we have to follow those same guidelines, then we have to label our A, B, C. Just remember that your C is always the longest side, the hypotenuse, and it's across from the right angle. The other two, A and B, are the sides that are attached to the right angle, and the A and B can be in either order. So this technically could have been B as well, and this one could have been A. That order doesn't matter as long as they're to the right angle. If we're to state the equation of Pythagorean theorem, this is A squared plus B squared equals C squared. And just note that Pythagorean theorem is only satisfied in a right angle triangle, which we have in this case. And Pythagorean theorem will also only find side lengths. You'll notice later that we'll be finding angles with some trigonometry equations, but Pythagorean theorem is only side lengths. So starting with the first one, we have to find the unknown side. So I'm going to call this x, and then we have to round it to the nearest tenths of a unit. So because we have a right angle triangle, we have two side lengths. We're finding one side length. We know we're going to use a squared plus b squared equals c squared. We have to label a, b, and c. And so if you remember, C is the longest side. A and B can be in either order, the sides that are attached to the right angle. So if we substitute these in, A squared is 8 squared plus B, which is 3 squared. And then we do not know what C squared is. And if we simplify these, we get 64 plus 9 equals C squared. And then we get 73 equals C squared. So the whole point of this is to isolate for the C. This squared is attached to the C, which is making it so that the C is not by itself and not isolated. If we're to bring this squared to the other side, we have to try and remember what the opposite of the squared is. The opposite of squared is square root. And so when the squared goes over, it now becomes a square root. And so the C value is approximately 8.544. And so C rounded to the nearest tenths, that should be a squiggle, is 8.5. And we have centimeters, so we have to include those as well. So on to the next example. Again, we're looking for the unknown side. And so I'm going to label this as x, and we're going to have to round at the end. So first, you should always start. We have a right angle. We have two side lengths, finding the remaining one. So we'll be using a squared plus b squared equals c squared. And so we also need to label the A, B, C. A and B are attached to the 90 degree. So I'm going to label this A and B, and C is always the longest side. So label it as C. So if we figure out what A squared is, A squared, well, that's 58 squared, plus B squared, we don't know what it is, so we called it X squared, and then C squared, which is 112 squared. And if we simplify, because again, we're trying to isolate for the X, 58 squared is 3364 plus x squared equals, and then 112 squared is 12544. And so if we're trying to get x by itself, we need to move this to the other side. This is positive 3,364. So when we bring it to the other side, we have 12544 subtract 3364. And so x squared equals 9180. And going along the same lines as before, we're trying to get x by itself. So the squared needs to go to the other side, which is the square root of 9180. And so x approximately is 95.8 meters. Now, I've had a few questions on whether some people were asking, instead of using this equation, am I allowed to just use a squared equals c squared minus b squared. This is just another way to memorize the equation. You can always use this equation and rearrange to this. It's okay to use this equation, but just make sure that you know the cases when you're supposed to use this one versus this one. So if you have any questions, make sure you write them down, and you can ask them in class. See you in class.